So with my capstone, I wanted to touch base on the testing portion of our project. The thing is, our project was very dependent on variables we did not know. So we wanted to dedicate a good chunk about this presentation to testing and really completing a very iterative approach to this project. When we first designed it, we didn't know a whole lot of factors such as how did light behave underwater, how did cameras behave underwater, how did salmon behave, what kind of things might structurally affect our project. And so we first tried to create a test prototype number one, as soon as possible. But before getting into that, so the first method we were going to use to detect fish had nothing to do with machine learning. We had no idea we were going to use machine learning then. What we were going to attempt to do was to use fish's eyes as a means of detecting fish. And so what I mean by that is if we shine a light for one frame and then capture that light and then take away that light and capture that same shot or a very similar shot, we should be able to do some subtraction, and that leads us to this. Theoretically, we can then draw contours around these illuminated circles, and voila, you have a bunch of fish. We can then use that to track whatever we want, but what we first needed to do was just get the fish in the shot in the first place. So I decided to try this out. Over the winter break, I took a Pi camera and I made a little program. This program would allow me to adjust various things within the shot, and it would constantly be toggling the light and then capturing every single frame with the camera. With that, I thought we could easily see whether this is a viable solution. And so I went to the hatchery, and the results were absolutely horrible. This is a complete non-starter. For one, I went during the off season for salmon, so I barely saw any salmon. But secondly, the glass got in the way. But thirdly, I realized that fish actually move far too fast for this to work. You actually need the salmon to be in pretty much the same shot from one shot to the next to be able to have subtraction be useful in any way, shape, or form. So seeing how that wasn't going to work, we decided to just build the system, get something in the water, and see what we can do from there. So we decided to try to use background removal algorithms for this first iteration. It's somewhat similar to the idea with removing the fish's body from an illuminated eye. But in this case, what we're doing is we're comparing one shot to the shot previous, and whatever is different remains, and whatever is the same gets removed. And we're thinking that in a stream, the thing that should mostly be moving would be fish. So here, we first tested this on a red ball that's moving along a ruler. You can see in this shot, this is a ball that's moving. This is obviously a stationary background, and it's being compared to the last shot. This is all that's different, and from there, we use a bunch of dilation and erosion to be able to say, oh, here's a moving object. Let's just count on that being a fish. So to give a general summary of this process, what we're thinking is we'll first remove the background. We'll then find the contours of what's left. We'll feed that into the tracker. And then if it crosses the center point, we count it. And then so on and so forth. This is a repeating process. So this is the system that we came up with. It was first made out of wood. You can see the LED in front, and we think we're good to go. I want to just take a second to introduce our two test subjects, Mr. Gray and Bluey. So when we put it into the water, see what happens, this is what we get. When we move the fish pretty slow, this tracker with the background removal is actually not too bad, but it struggles with reflections and it struggles with bubbles. Here's Bluey going every which way. But as he comes back into the scene, yeah, we're able to count him. So that's a pretty big milestone for us. we got our first phase of testing done. But that begs the question, can we do any better? I think we could. The thing is, it's not just a fish counter, but it's a stick counter, it's a bubble counter, it's a reflection counter. You can see that there's reflections here, and it's not easy to remove these in any meaningful way. So the problem with this method is it's hard to improve upon this. Really, what we have is what we have. Background removal only goes so far, and then tracking can work with what it has, but if you're detecting bubbles, if you're detecting reflections, you're toast. And secondly, we needed a more permanent frame solution. I didn't mention this, but this wood frame actually floats, and that makes it very difficult to actually put it in the water. You have to weigh it down. So this leads us to our second iteration. You'll notice that this frame is made of galvanized steel. Another thing that you wouldn't notice because it's not in the frame, but at the back here is a pie coral. I'll get to that in a second. But what we really wanted to do is test this with real salmon. So we took our system to the Seymour hatchery. It's beautiful up there, and the people there were very, very kind to us. They allowed us to use one of their tents to put our system in and see just what happens. We spent hours there, and we recorded a bunch of footage. Here's an example of some of the footage we got. This is about the time that we replaced our background removal to find contours with machine learning. The pie coral came in very handy here. We wouldn't be able to use any machine learning algorithms without it. The PyForge simply cannot handle it. To first develop the machine learning algorithm, though, we tested it simply on pictures. We spent quite some time developing a model. We weren't able to detect species of fish. We can't tell if it's a salmon, never mind the different various types of salmon. But we're able to tell that it's a fish. So we took the footage that we got from Seymour Hatchery and we ran it through our algorithm. And this was the end result. You can see that it's much more robust. It can handle multiple fish at the same time. You can see there. And it's impervious to the bubbles that are on top.